So we're on the last lesson of the unit, 8.4, and it's multiplying special cases. So we have a new vocab term today, and the term is conjugate. And these are binomials that are opposites. So as you see, the example is x minus 3 and x plus 3. So this is one type of special case of binomials, and the other special case of binomials is squaring a binomial. So those are our two objectives for today. I can square binomials and multiply conjugates. Before we get into the binomials that we're used to seeing with the variable, we're going to take a look at evaluating an order of operations question, because there's a common mistake that students make when they're multiplying binomials, and I want to make sure we avoid that. So when you take a look at this, order of operations, the first thing we do is grouping symbols. So we've got our parentheses, 6 plus 2 is 8, and then 8 squared is 64. Now what students typically do when they see a binomial with a variable, for example, if they were asked to evaluate the quantity x plus 2 squared, they might try and distribute the square. So let's evaluate this a different way by distributing the square. We would get 6 squared plus 2 squared. 6 squared is 36, 2 squared is 4, so we would get 40. So those are two different ways to evaluate the same problem, but only one of them is correct. And that's this first method that we use right here. So make sure that when you square binomials, you understand that you cannot distribute a square into a sum or difference. We did look at distributing into multiplication and division, and that's okay. You can't distribute into a sum or a difference, plus or minus sign. So how do we evaluate binomials? Multiplying them. What you have to think about is what it means to square something. And what it means is to multiply it by itself. So we rewrite this as x minus 5 times itself, x minus 5. And then we either use distributive property or the box method that we've already seen. So once you have it written out the long way, it's no different than what you already know. So we're going to start by distributing the x, which is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. So when we simplify, we'll combine our like terms in the middle. Negative 5x minus 5x is negative 10x. So we get x squared minus 10x plus 25. So now that we have the method down, we're just going to look at some that are a bit more complicated. So my first one here, again, I'm going to rewrite it as 4y cubed plus 1 times itself, 4y cubed plus 1. And then I'm going to distribute. So I've got my 4y cubed times 4y cubed. Remember, multiply your coefficients. So 4 times 4 gives me 16. And then multiply your variables. Y cubed times y cubed. We add the exponents and get y to the 6th. And then I'm going to do 4y cubed times 1. And 1 times 4y cubed. And 1 times 1. So I've got my two like terms in the middle, which will always happen when you're squaring a binomial. Those two middle terms will always be exactly the same. So we got 16y squared, y to the 6th. And then remember, when we add like terms, we add the coefficients and we leave the variable alone. And then our plus 1. Last one. For this type of example, we still need to know how to multiply conjugates. So again, write it out as the binomial times itself, and then we're going to distribute. So we get the 2m squared times 2m squared. 2 times 2 gives me 4. M squared times m squared, we add those exponents. 2m squared times negative 7n to the 5th. 2 times negative 7 is negative 14. And then these are not the same variable, so we can't combine them. So it's just m squared n to the 5th. And then right here we have the exact same thing that we just did, so I don't even have to think. I just write it down again. And then we have negative 7n to the 5th times negative 7n to the 5th. Negative 7 times negative 7 is positive 49. And then remember, when we multiply variables, we add the exponents, so we get n to the 10th. The next type we're going to look at is multiplying conjugates. So hopefully after a couple of these, you'll see a nice pattern that happens, and multiplying conjugates is actually easier than multiplying regular binomials. So we're going to take a look at distributive property. X times x gives me x squared. X times positive 9 gives me positive 9x. Negative 9, sorry I missed one, negative 9 times x is negative 9x, and negative 9 times positive 9 is negative 81. So we're going to combine our like terms in the middle. We've got opposites. Remember, conjugates are binomials that are opposites. So those two terms in the middle will always be opposites. And what do opposites do when we're combining them? They cancel each other out. So we're left with x squared minus 81. And just so you know, remember that positive 9x minus 9x cancels. So my next example, I'm going to do the same thing. 3x times 3x is 9x squared. Remember to multiply the 3 by 3 and the x times x. 3x times negative 2 is negative 6x. 2 times 3x is positive 6x. So we've got those opposites again. And 2 times negative 2 is negative 4. So those middle two terms are opposites, so they cancel, giving us 9x squared minus 4. So here's a shortcut that only works with multiplying conjugates. I'm a little nervous teaching you this because I don't want you to skip this step with regular binomials. But if you have conjugates, if you look and your binomials are exactly the same, but one's positive, one's negative, you can get your answer by doing the first terms times each other. So 4f times 4f is 16f squared. And then multiplying the last terms, negative g times g is negative g squared. Because what will always happen is what we just saw in the last two examples, those middle two terms when we distribute. So in this case, it would be positive 4fg minus 4fg. Those will always cancel. And the last thing we're going to take a look at is finding the area of a shaded region. So my two examples here, they're both squares. So how do we square x plus 6? So the first thing, let me back up. The first thing I'm going to do is find the area of the large square, which would give me the area of everything, including that white piece in the middle. So then I'm going to subtract the area of my smaller square, and that will leave me with the area of my shaded region. So to find the area of a square, remember you do side times side, or side squared. So to evaluate this, I'm going to do x plus 6 times itself. And then I'm going to get x squared plus 6x plus 6x. So what happens with squares is that middle term is always the same, so you can just double it. So let me write this out the long way, and then the next one I'll do the shortcut. And then 6 times 6 is 36. So again, notice these middle two terms are exactly the same. So I get x squared plus 2 6x's, or 12x, plus 36. But then I need to subtract off the area of my purple square. So I've got x minus 1 squared, meaning times it by itself. So I get x squared, and then I'll have two of these, negative x, so negative 2x, and negative 1 times negative 1 is positive x. So again, I have to take the area of the blue square and subtract the area of the purple square. So I'm going to take this as my blue square. And what I have to do is distribute that subtraction sign through my second polynomial, in this case trinomial. So it becomes x squared plus 12x plus 36 minus x squared plus 2x minus 1. Make sure you distribute that subtraction sign through the entire second polynomial. So now combining like terms, I've got x squared minus x squared, so those cancel. And then I have 12x plus 2x gives me 14x.
Good morning. Would all proctors please report to the
minus
multipurpose
1
room if you have not picked up your
negative
materials
35.
for testing today? All proctors who have not picked up their materials, please come to the multipurpose room at this time.
Sorry about that, I would have to start all over, I can't pause my videos, so we're just gonna go with that little announcement in the middle of our lesson here. Alright, so my next square, my red square, my large square, is 2x minus 2 on each side. So remember, I'm going to do 2x minus 2 squared to get the area, which means multiply it by itself. So distributing, I get 2x times 2x is 4x squared. 2x times negative 2 is negative 4x. Negative 2 times 2x is negative 4x. And negative 2 times negative 2 is positive 4. So combining my like terms, I get negative 8x. And then my green square is x. So to get the area, I'm going to multiply x by x and get x squared. So to find the area of the shaded region, I will subtract x squared from the area of my red square. And I have 4x squared minus x squared gives me 3x squared. And then minus 8x plus 4 have no like terms.